Hey YouTubers, I'd like to welcome you to my first video. If you like watching people build things in interesting ways, I suggest subscribing to my channel. I'll upload new videos every week. Let's get started. This week, I built a 3D printed chalkboard with light bulbs, spaceships, funky looking apples and pyramids, along with a chalk rail. This project was an experiment at first. I wanted to know if there was a way to improve upon the construction of picture frames by removing the 45-degree corners from the build. You see, my daytime job is a picture framer, and the corner joints can become tedious and imperfect. So I came up with the idea I could construct 3D printed corners that are customizable and result in a perfect corner every time. Before I can test my printed corners, I need to model my frame boards and build them in the wood shop. So that's what I'm doing right now. I'm modeling a frame board that's roughly 2 inches wide by 3/4 of an inch thick and has a 1/2 inch by 1/4 inch notch cut in it. I believe I'll also remove the sharp edges on the top with a 1/4 round fillet. Now I'll go ahead and place this 24-inch board into the assembly program and assemble these two boards together, making sure that everything is on the right plane and are dimensionally correct. Once I do this, I'm going to go ahead and build the 3-foot board by using the 24-inch board as a template. I'll just go ahead and edit the extrusion feature to 36 inches. It makes things really easy. Now let's go ahead and assemble the frame boards into their final spots. Assembling the frame boards. Okay, let's make everything on the same plane and constrain it out to each other. This way things don't fly around when you move around. Time for an extreme woodworking montage. 1. Measure the board and cut it. 2. Plane the boards down. 3. Joint it with the jointer. 4. Rip the board to 2 inches. 5. Put the notch in the board. 6. Trim the board to the final lengths. And finally, number 7. Remove sharp edges with the router. Yes! Work with that wood. Do it faster. Faster. And be done. Okay, so I came back with a little sliver of wood that I did, and I have my calipers here, so I'm gonna go ahead and measure everything and update the dimensions so that I have a pretty good idea. When you're measuring, you probably want to get down to a good 5/1000ths of an inch.
No, 1/1000th of an inch.
You're not going to be able to measure it exactly.
You can measure to 1/1000. I know you can.
So don't be too stressed about getting things the exact same dimension.
I'm stressed about it.
Just have everything a rough dimension. You don't want to be on the smaller side. You want to be on the bigger side of things.
The bigger side of life.
So once I get done updating the frame board with the correct dimensions, I'm going to go ahead and build a test piece for my printer to print out so that I can measure it and see what type of offset I need to model with. This way I can actually model one time and print one time without having a bunch of failed prints.
3D printer!
Knowing your printer's offset is very important.
Look at it go!
When it comes to modeling. That way you can get things right the first time. Alright, let's go ahead and start modeling that corner. Right here, we'll just go ahead and get the rough dimension of the corner. We'll set things equal to the frame board, plus we want the frame board to go in the corner about 1 inch. And we want it to be the same height as the frame board. Now let's go ahead and add the material around the frame board, what's actually going to hold the frame boards in the plastic corner. So we need to add a little bit.
We need to add 1/8 of an inch, plus the offset of the printer, which is 35 thousandths.
Okay, so we'll keep the 1 inch dimension, and then we want about 1/8 inch of plastic holding the frame board in. But we also have to account for the offset of the printer, which is 35 thousandths, and we'll divide that by 2 because the board is actually inside, is going inside. Once we got the sides, let's go ahead and do the top and bottom, adding about 1/8 inch to the top and bottom of it all.
Plus the offset.
And we'll go ahead and project the geometry of the frame board and add our printing offset, which is 35 thousandths divided by 2, and remove that material. There's a rough idea of the actual frame board going into the plastic. However, we need to remove some more material so that the chalkboard will fit into our frame. Now this dimension here needs to be pretty small because it's going to affect the actual size of the chalkboard. However, I can't go smaller than a 1/16 without it being structurally unsound.
Hey, it doesn't look like a box anymore.
And it looks pretty good. Let's go ahead and do the same to the other side real quick. We'll add our printing offset and remove some more material.
Unwanted material, be gone.
And we have this little notch here, so let's go ahead and remove that notch real quick.
Goodbye, notch. Go away.
Alright, so in theory, this corner should give us a 90-degree angle and hold our frame boards together. Let's go ahead and add some artwork to the top of it.
And make it look beautiful.
I'm going to go ahead and use an image of a light bulb to help me model.
Why? 'Cause you can't draw it free-handed.
We'll go ahead and set this image up, straight up, and get it constrain it to our actual plastic corner that we're modeling. Once we get it all constrained out, we can start using it as a reference to set our light bulb profile. Now, using the spline tool, we're not really using any dimensions here. We're just kind of following the edge of the image to help us get a good idea of what a light bulb should look like in a 3D world.
You're not doing very well. You need to readjust. Readjust it.
We'll revolve it. There we go. Revolve it 180 degrees. There's a light bulb. Now let's go ahead and add a hole to it so that we can mount our chalkboard on the wall. Now, we want our hole to have a countersink, and typically you could get away with a screw's diameter being 1/8 of an inch. However, we don't want a 5-inch screw, so we'll countersink it to where there's about a 1/4 inch of material and offset the countersink so that we can have a 3/8 dowel rod go into the hole.
Now it's time to do a rough assembly. Looks like everything's fitting together pretty well. Sand the boards, clean the boards. Stain the boards with ivory stain. Then seal the boards with the polymer. Polyurethane sealant by Minwax.
Everything's done by Minwax. Make things look beautiful again.
Are you done yet? Why does staining take the longest? Hurry up and be done with staining the boards. It's just black stain. Yes, be done. Hurry up. Okay, build the chalkboard. Yes. Cut a piece of plywood down to 2 foot by 3 foot. Cut it. You must have got that plywood for free because it's painted. Now sand the plywood down. Make it nice and smooth like. Then clean it off with air. And now paint it with chalkboard paint. Yes, paint it just like that. Make sure you do an X pattern with the paint so that everything is nice and level. The paint is nice and level when you do an X pattern. Hurry up and be done painting the plywood.
Yay! 3D printer time! So much printing! Even more printing! Oh my gosh!
Hey, what are you doing? You're destroying the part you just printed. Why? Why are you destroying it? It was so pretty. So after removing all the support material, I used a soldering iron to smooth down all the bumps and ridges on the inside. It really worked out pretty well. I think I'm going to continue using this soldering iron trick to help out other parts as I print out, because not everything ends up perfect and some things do need to be removed, but the soldering iron, you don't have to get a knife out and try to remove it. You can just smelt it down. It worked out really well. Time to assemble the chalkboard. Finally! So after spray painting my blue parts black, everything turned out pretty well. And now I'm just gonna go ahead and screw the boards into the plastic and make everything join up correctly. However, I did have some melting issues on the black PLA, printing out the light bulb and the spaceship. The PLA that I used wasn't the best. It was really cheap, and I don't think I'm ever gonna go back to that brand again, just because I had so many problems with it. the PLA wouldn't even roll off the spool to go into my printer. It would go a little bit and then just break. It'd snap apart. It was so brittle. It was a pain to print with. Thank you for watching my video. I hope you enjoyed it. Please feel free to subscribe, hit the like button, or add comments. Or not. Over here we have the build list. If you have a suggestion for a future build, please click on the video and leave your idea in the comment section. And right here is a sneak preview of the next video in line, Austin's 3D printed gift. I'll see you next time.